Hi and welcome. Today I'm going to talk about Java programming. So this is not a Java programming tutorial. It is more like a Java object orientation guideline tutorial, thoughts about security when you do programming with Java, of course. So just gonna create some classes. I am, by the way, in the program called IntelliJ. Again, the program itself is not that important. It is more about choose the editor you like, and I chose IntelliJ. So I'm going to create a Java class. I'm just going to call it main, like that. And of course, we need to have a public static void main in order to run our programs. So let's talk about when you create a new class. So I'm going to create a new class now. I'm just going to call it the demo class. And there you go. Now, so far so good. We have a public class and it's in the file called demo, which is Java's convention. The only public class in the file should be named the same. Not should, but have to be. So I'm going to talk about whenever you create the things called fields, or you call it the class, okay, variables, or whatever you could call them. Then you have another called the methods, and that's really what the class is all about. So when you create the fields or class variable, whatever you want to call them, I see many people just write string just like this and name, for example, and just off the bat, if you're just learning to program and you just I want to create little small program to take a name and stuff like that, it's fine. But think about it this way, that all your fields inside the class should in theory always be private if it's something that should be worked with inside the class itself. Let me explain this a bit more. So let's say this value here, let's just give it some generic name, value. This value here is something that the methods are going to work with, not something that you are going to get out just as a literal value, but something you're going to work with. This value should always be private. And it basically means that you're going to create a public method. Let's just call it work with value, just like that. And then you do something with the actual value and say this value equal value, and then you concatenate the letter and a space called new. That is what this very interesting method is doing. So this is basically one method doing one task, and the task is to add this text to the value. Okay, so this is a more correct way if you want to think about security, like your private string value is encapsulated correctly. Alright, so it's also called accessifier. You can have public and private and protected and stuff like that. What you also need to think about next is how to use the methods correctly. Now, this is a type of method that works with the value. It doesn't return anything, but does it set something? Yeah, you probably notice getters and setters, so I'm going to write getters and setters. The reason that I divided them into different, categories is because basically this is not really either a getter or setter. It doesn't really get anything. It doesn't really set anything. You could argue that it append a value, but depending on nothing, it's just a literal value. So it kind of would need the argument to be a real setter. The getters and the setters could be created by just right clicking IntelliJ and say something like generate, and then say getters and setters, and for this value only, and then you get the two getters and setters basically for the value variable. By having this, you have some standardized getters and setters, but that is not enough, right? Because in terms of security, this can be misused in many ways. Now let's assume that this getters and setters was an int value. Now I need to alter a few things here in order for this to work. Alright, so let's just remove this method here and return to getters and setters, because this is where the point is. So let's assume that I now call the value get value and I return whatever value it contained. Okay, so maybe that should be changed a bit. So depending on the actual min and max value that you should ever return, you should check for that within the code. Something like if the value is less than 0, for example, if that is what you want to check for, then you should definitely not return anything negative and just return the number 0. I guess you kind of get the point. So whenever there's a sort of value you can check for, make sure you just don't blindly return a value without knowing exactly what the minimum and the maximum of whatever value. This is an integer, so it's easy to say min and max. If it was a string, it should be like length of the string, it could be types of letters, types of whatever it contained, different kind of things that could be inside of it. What is it you are returning? Is it something from the database you fetched somewhere? Are you going to work with that value in your getter in some way? Because you could create a getter that had some sort of, argument, like I said, a boolean. Let me just create a simple one, boolean true, some easy one. So if you have some, let's say, argument called boolean fixed. So if you need a fixed value, basically that you only need to return a certain type amount of that value. So that could be an argument inside your method or your getter that you needed to ask for within the if statements or the conditional. Now, depending on this, I hope you have the mindset right now that you can not just blindly return the value. You need to make sure, like, what is it you're returning? Of course, this one conditional doesn't really make it up for all of it, but it's just, in order to explain it, you just need to think about every method you have. Where does the data come from? Right? Where does the data come from? Where is the data being outputted to? Now, that is probably not inside of this particular method you're going to do something about it, because if you're outputting the data to, let's say, a view part for a web application, well, then you probably need to do some encoding or some cross-site request mitigation, stuff like that, which is not done in this class. That should be another class fixing that issue. Same when you are setting a value. Of course, when we have integer values, you always need to have some sort of mindset of the min and the max. So it could be like if the value is larger than 0 and the value is less than 100, so that would be 199. So anything from 1 to 99 is allowed. That would be this, else we will just return. We will not return because it's a void, else we'll just do basically nothing. That could be one way of making sure that you cannot just insert any type of value inside this integer. Again, I would like to say, could you point out an issue? If this was your if statement, what would the issue be right now? And it's about this variable here. Please pause the video a few minutes and think about it. Yeah, you probably already guessed it. So if you have a value that only contains a very insignificant small number from 0 to 100, the int is probably too much. Depending on the language you're in, there could be different kind of variable types. Maybe small, but in Java there's no small. It could be basically anything. I'm just clicking to show different kind of possibilities. gonna have like a byte, and the byte itself could be from 0 to 255, and what really happens here is that I need to change this value here, and then this would work. Just restricting the amount of memory that I'm using while compiling the program or running the program by choosing the right amount of size variables is really important, also when it comes to security. I know you might ask why. Well, in this particular small example, I wouldn't give a damn ass about it, but bigger, larger systems, if you can save up some memory, well, then it's a good thing, because it uses less. The more memory you use, the more consumption it's gonna be, and depending on that, it could, lay down the server in some way, or use too much memory, or just crash in certain scenarios because you didn't think it in as a design. So security by design even starts by choosing the correct variable types. Alright, so this is some of the things that I would like you to think about whenever you're creating a class that contains some sort of value, working with the value in some way, and this is basically what it is. Another way for you to get around is to have your methods again, and sometimes you also need to have some private methods that can return, let's say, some value. Let's call it work with value, and let's just give the value like this, and let's say return. Let's create a variable called value here, equal it to this value. I'm just improvising. I'm gonna return value, and basically what I'm gonna say is value equal plus equal v. Okay, so this could be a typical method where you just add some, some value, and you might ask, why did I take a copy of it inside of this? Why not use it direct? You could do that, and just to show it, in this particular case, I have no real reason to do it like that, but I just want to show you that it is possible to take a copy of whatever you're working with and actually not work with the actual value, but you're working with a copy of it. Of course, this doesn't return or modify this value at any point in time. It only takes it, store a new one, add on whatever is inside the V, and return it. Now, you might even see the issue in this method. Again, this is just a typical programming error. I'm going to give you a few moments to think about it. Alright, so you might even saw it and, guessed it. I'm using the integer again. This is very normal for programmers just to type int because, it's a small value, I don't need anything, I just need to store age. If you need to store an age, you might not even need an integer. Maybe a byte could do it, maybe even less. Let's remove the word byte again and just look at whatever things there are possibilities. Char is not it, double, no, never. Short, it's still too long, so I would say in this particular example, byte might be the correct value. Of course, you will need to change this to byte, that to byte, and that to byte. So we still have another issue in this method. Maybe you can guess it. Yes, we're going back to the actual setter problem again, that we do not check the value. So what would actually happen if you overflow the value or to try to put in some value in this variable that is not fitted? Now, Java might not do much, but other languages will crash the program. Or on some occasions you can do buffer overflows and stuff like that, which is really bad for you. So I highly suggest that depending on the language you're programming in, you go and read up on the whole thing about the value part. I talked about what is the actual max and min value of a variable and what happens if you overflow it. Now, just to give you an example of this is my main file. I could go and create a byte, let's say, and just call it temp equals it to 0. I could output that to the screen and run the program. Now this is of course Java, and it is running in the JMV, Java Virtual Machine, and it outputs the number 0. What happens if I try to put 255 in, which should be the max value? Okay, so it kinda say no thank you, let's try one less. No. So depending on what is the max size of this byte, you know, I'm like, wow, okay, I don't really know. So I'm just gonna cast it to a byte and see whatever it comes out of it. So I'm running the program. It says -2. Very interesting. So does it actually want to save the value 100? It does. 200. 200. And you can see that there is a certain limit to the size of the value. Now I'm not by any means any expert in value sizes in Java. I just figured, well, maybe byte is 255 and min is 0, which I said in the beginning why I chose the byte. Now, without knowing the actual max size, I cannot do the work of this. So maybe I should go and read what is the actual min and max value on a byte. So let's bring in a search engine and write Java byte min max value. And it kind of says in the document here on the Oracle website that the byte is a data type 8-bit signed. So signed basically means that it can go negative to -128 and it can go maximum of 127. And there's a list of other variable types. You can see that byte is 8 bits, short is 16, int is 32. Let's see if there's other ones we can use. And it doesn't really look like it. So basically, what we need to make sure now, when we're using the variable of the primitive type of byte, is to make sure that we do not exceed or extend or go beyond the max and the min value. So I'm gonna go back to my program, to my demo program, and say, okay, so I'm trying to add on this v. This is happening here. So the first line here, 8, just copies whatever values inside the one byte and inside the other byte. Just right now off the bat, I can tell you that the value is not being checked enough inside the setter. Oh, actually it is being checked enough. Just by chance, I put it within the correct parameters of -128 and positive 127. Now I could type that in here, but I'm gonna stick to this 0 to 100 for now. So what I really need to do is, and you probably already guessed it, that if I add on this value to this value, I need to check if those two together is okay. So some might say, but couldn't you just do try catch, like try this and then do like a catch? Okay, so if we did that, I just do some like this and the get message. And what we're gonna do is we take this here. Now maybe it's time now that we actually run the program for real. So what I'm really gonna do is I'm gonna go into my main. I'm gonna create a demo d equal new demo, and what I'm gonna do is say d set value 100, and we have an error right now telling that we cannot do this. So let's see the set value. One related problem. It tells me that the word value is probably not the issue here. It tells me that cannot be applied to int. So I'm gonna cast it and give it the value 100. And what I'm really gonna do is say, let's get the value. So it doesn't work the way I'm expecting it. It's a integers, let's change this to byte. So let's go back again and say, I'm gonna output this and say d get value, run the program. And what I should see is I'm seeing 0. So something doesn't work inside the set value. So let's look at this for a second. It gets in and it's not being added. Let's do an else here and say did not work. And let's run the program. Now this is just a really easy debugging way for you to see what's up and not. So it did not work. So the thing is, what really happened here? We can just append this value here. Let's say appending the value, run the program again. And let's see, it does say the 100, but it's not being added here. So let's see what the question is. It says value. Is it larger than 0? It is. Is it less than 100? Okay, so 100 is it less than? It is not, because it is 100. So we could put in like an equal sign here to say if it's also 100. Let's run the program again. And now we see 100. So let's delete this again. Go back to the main and say, all right, so it's being appended. So what if I do call the program work with value now? So I'm going down here saying d work with value. Why can I not see that? It's a private method. I'm sorry. So let's say public. You see how easy it's forgetting. So I'm gonna tell it to add 30. And it wants me to cast this to a byte because it tells me that it's an integer. Let's just copy this to there. I'm gonna run the program again. And it still tells me that it's 100. Let's look at the work with value program just for a second. So what it kind of does is it's trying to add this to the value and return the value. So really what I need to do is to output this to the screen. And let's just remove that output there and take this. It should say 130, but it's a minus 126. So this is a result. Let's just do something like this. And this we expected 130, but we got a minus 126. Of course, this is no secret. So let's just go back to the byte again. And the max was 127. And the min was minus 128, if I'm not mistaken. We can just go have a look again if we forgot it. And say Java byte min max. So it kind of tells me there, but I'm just going to go here and say maximum of 127 and minimum 128. So this is the max. This is the min. What is really happening here is I'm getting 127. I'm adding 30 to the 100, and that is too much. So it's deducting the extra byte that is larger than 127 and return us 126, but in a negative number. We did not expect this. If you are a programmer and you were expecting 130, but you're getting another number. You have a hole in your program. That hole in your program did not result in any try and catch error here. Please be aware that when I told you that someone would tell me, oh, just put in a try and catch clause, yeah, in some programming languages you would need to do that because it would crash the program. But Java is a more secure programming language, which basically means that the Java virtual machine say, yeah, I'm just gonna roll it. So instead of adding, it's just rolling the values. Basically that means that in the actual 127 positive, it says minus 128 minus 127 minus 126. So basically what happens is that it's just stepping over it. It's just a list of numbers. It's being stepped through. So it's like a wheel in a way. It's a never-ending loop. Depending on which number you add, then you will get another negative or positive number. That is a security flaw which could be tweaking the system to a certain way, or to a certain extent, where you would get a product or minus product or deducted a price or unrespected results and so on. That is why it is so important for you to check your values, check your documentation, and so on. This is just one small video. I'm talking about something very simple as a value. I've demonstrated what it can do if you do it wrong, and talked about what you should do. And what you should do, I'm just gonna mention it again. You need to make sure you can keep the try catch if you want to. I would say it's probably not a bad idea in this case. But what you really need to do is to find out whether these two numbers is exceeding or not. So you could do something like an if statement here, as saying that if value plus v, if that is possible to do, need to put it in parentheses, I guess. No. So I need to take, let's see. So you could take the values and ask if they are larger or below. So the maximum would be 127. So that means that the value plus that cannot be larger than 127. So as long it is less than or equal to 177, this would be okay. Else we need to output, just for clarification's case for this video, that the two numbers go over 137 positive. So let's run the program again and see what happens. And it kind of says that the two numbers go over 127 positive. It still outputs the 100, which is why it's never being added, the 30 here. So work with value is returning this value, which is the value of whatever I input in the start to the value variable, and this happened here. If I take the value 27 and run the program again, in theory it should work now and say that the maximum value is 127. If I then do 128, it should again not allow me to do that, and basically tell me that the number goes over 127. I should output the number 100, which is in the top. So this is the work you kind of need to do. And trust me, almost no students I've been looking at computer science educations does these kind of things. It is a major problem in my eyes that students are learning these kind of very simple basic terms. Know the max and the min value. Check for it. This is basically what I'm doing. I'm not doing any complicated math or, oh, this is advanced stuff. It is not advanced at all. It is toenail stuff. Okay? It is basic baby steps. If you're doing the kind of things, many security issues will just dissipate, because it's all about the number and the value. So I can continue talking, and the video is about 30 minutes long right now. Basically what I'm telling you is, please mind your values. This is just one video. I'm gonna try and create some more videos about secure programming. This was with Java, and I hope you liked the video. I hope you subscribe to my channel and like it. If you have any questions, please just put them below and I will come back to you. Until next time, bye bye.